Welcome, good morning, whatever time it is. Welcome to lesson 25. We're going to be talking about the difference between a relation and a function. And we already mentioned functions before. We had those math machine things and talked about bread and toast and washing machines and whatnot. So more of that today. So let's get right into it. We do have some serious vocabulary to discuss, so if you've got your notebook, you're going to want to have that down, and if you're looking in your book, there are quite a few terms there for you to get down. Remember, you can hit pause at any point here and do that. Let's start off with just our basic ordered pair up here, x, y. If you recall, with the math machines, there was a number that you plugged into the machine and then a number that comes spitting out. It doesn't even have to be a number. It just has to be that something that goes in has something done to it and then something else comes out. Well, it doesn't have to be something else. But we have two parts there. And the parts that go in are typically referred to as the domain. I'm going to use that big capital D for domain. When we go ahead and do graphing and make charts and tables and things like that, that first thing that goes in, the domain, is always the independent variable. That's the part that we get to pick. Okay, that's the part that we decide what it is that we would like to evaluate or to see what happens when we run it through a math machine. The independent variable, I get to pick. And on a graph, the independent variables are the ones that lie in the horizontal plane. They lie horizontally. That's how you're going to find them and pick them and then go up or down to find out where the range happens to be. Okay, that's associated with the x variable, the independent variable. All the independent variables that you put into your machine makes up a set called the domain. Secondly, the range is associated with the y values. Okay, the range goes with the y values, and they are also called the dependent variables. They're all the things that come spitting out of your machine. Okay? And on a graph, they're associated with the things in the horizontal plane, the horizontal direction. And again, they're associated with the y-axis or the y values. And so that entire set of numbers that come out or things that come out of your machine are called the range, the set of things called the range. There's a slight distinction then between relations and functions. Let's just say this, all functions are relations, but not all relations are functions. And there's one key difference that we'll see when we draw the pictures for these things, when we show you all the different ways that we can represent relations and functions. And that is that relations start off with something over here, run through the machine, and you can have then one or more different outputs. Put in one thing over here, you run it through your machine or you run it through your thing, and then out comes one or more outputs. And the relation thing is that it can be or more, right? So let's say you put in the number 2 and out comes the number 4 and -4. That's a relation. It's a function if you put in one thing over here and you get one thing over there. Put in an x and you get out one number for a y. Okay, that's what makes a function different. There is what mathematicians call a one-to-one correspondence only with functions. That I put the thing in and it can't become more than one thing. It can only become one thing when you run it through the machine. Now there are different ways that this gets represented then. Sometimes we just go and we're going to collect all the numbers that we're deciding to run through our machine, and we list those things in a set. So oftentimes, set notation, you can just have something like this. They'll say the domain is made up of, and typically then you use braces here. And then they'll list all the numbers that you're plugging into your machine and then put the end brackets or braces there. And that would be the set notation for the domain. And then you get a separate one that lists the range. And sometimes from just seeing the domain and the range, the list of numbers there, you can figure out what the function or what the machine was to turn the numbers in the first list into the numbers in the second list. And maybe you can see what I did there. I'm plugging in a number in the domain and out comes a number in the range. Now when you list them though, they're typically listed from smallest to greatest. They don't have to be. You can put them in whatever order that you want to, but if it's a function, you would see some type of one-to-one correspondence. This number turns into this number. They all turn into that other number in the same way, using the same type of operation. So set notation is one way to represent a relation or a function. You just list the numbers that go in, and you list the numbers that come out. Okay, that's the first way to represent one of these types of relationships. The second one's a table, and we've done these kinds of things before. One version of that table is a thing called a T-chart. So I made the letter T, and then I put a column for X and a column for Y. And I just start listing the numbers that I'm putting in. Remember, X is the input, or in a sense it was the domain. And then I start listing next to them the numbers that are the output numbers. And these things can very quickly become a list of ordered pairs. So there being another way, we could list them instead of in a T-chart or table, we can start listing them as actually a set of ordered pairs. That is, we might put the brackets in there and we'd say we've got the number for the spot 2, 4, we've got the spot 3, 9, and we've got the pair 4, 16, and we got the pair 5, 25, all in their own little set of ordered pair parentheses deals. So that could be another way of representing a relation or a function. Those are all totally valid. They're just not the ones that we're used to. Let me talk about diagrams. Okay, this is one that you'll see in tables. Diagrams. They'll use this it kind of looks like it should be a Venn diagram, but they'll have kind of one grouping over here and one grouping over here, and then you'll have either your function or your relation that's saying those numbers go over to these numbers. So maybe they'll do something like this. Maybe not necessarily list them in order, but there's our collection of inputs, and then we'll have our collection of outputs, and we draw a line to show which ones are associated with which other one. Like playing connect the dots kind of thing here. And again, they could be in order. They don't have to be, as long as we're showing, in this case being a function, a one-to-one correspondence between this set, which is the domain, and this set, which is the range. So we're doing the exact same thing, we're just representing it in a different way. There's one in the book there that has an interesting little problem, and that would be something like this, where it has an extra bit in there, and it has one number on the left going to two different numbers on the right. And that is fine if you have a relation. We said that was possible. But this would disqualify this particular thing from being considered a function. There has to be a one-to-one correspondence. Now there's another thing that could be true as well, and it still be a function. And that is, what if that 5 doesn't go to the 25? What if that 5 goes to 4? That's fine because you still have a 1 number over here that goes to 1 number over there. There's only one line leaving the number over here on the domain side. It's going over to the range side. So that is a function as well. Okay? So you got lots of different styles of these things that can represent the same thing. Set notation, a table, a diagram. You can even have it go like this. You can have your x's and your y's and list them this way. You can have cost versus time. You can have whatever your variables happen to be. The last one that's probably the easiest to see because it's just a picture would be the graphs. Graphs could be a line, it could be a parabola, it could be a thing with lines and circles and whatnot, like that, piecewise type of function or step function. But typically you're going to get something like this or something like this. And there's a pretty easy way to test whether your graph of a particular relation is just a relation or if it's reached the next level and become a function. And there's this one-to-one correspondence. One-to-one correspondence can be checked with like a stick or a line. And you start going down and you can see you hold your line vertically and you decide, well, could I cut through this graph in only one place if I draw a vertical line? It's called the vertical line test. And if your picture passes the vertical line test, where that line, if you move it along from left to right, will only cut through your graph in at most one place, that is considered a function. So let me show you what a relation would look like that would violate that rule. Because if you took something like a parabola and you turned it on its side, this curve shape here, well, if you brought your stick across, you'd see that at some places you're going to cut through that graph in more than one place. Some places you don't cut through anywhere, some places you only touch it once, but there's going to be some places where you cut through it more than once. That means that if you went out to some value on the x or the independent variable axis, and then went up to go find out where on the y-axis that it's intercepting that thing, you would get two different values, one right here and one right here, that go along with a y value. And that would be not okay. That means it's only a relation that it doesn't pass the test of being a function. Again, that's called the vertical line test. Very important mathematically and very helpful for visualizing what's going on there. So they're going to give you some sets, tables, diagrams, and graphs for you to evaluate to see if this thing is a function or if it's only a relation. The last thing to do would be talk about a thing called function notation. If a relation is a function, it can be written as a formula. Now we usually will see something like this in math, how you would graph a function. You've got an independent variable and then you do the machine and then out comes your other one. But instead of writing y, they'll write this. They'll say there's some rule, a machine, and they're basically just telling you what the machine is. And they do this thing here, and this is called, you're going to say it this way, f of x. F of x is 2x plus 2. You still will then plug in, if you want to evaluate it, you plug in a number right there, and you say, I want to check on the number 1 when I run it through my machine, and this is what happens. And that automatically leads you to say, this is what I plugged in, and this is what I got. It leads automatically to an ordered pair. Okay, so that's called function notation, and what I just did was evaluate the function. Basically, all you're doing is you're replacing y with this thing here, f of x, and then you can plug in a number, see it right there, plug it in, and see what the answer is, generate a ordered pair. Okay, so that should be enough to go on today. Look for the functions, look for the rule, look for the one-to-one correspondence for functions. You're going to have that rule broken if it's only a relation. And if you have questions, please bring them to class.